Hello, it's Katie from your favorite field trip destination, the Wenatchee River Institute, and we are not on our campus in Leavenworth today. In fact, we are 15 minutes up the road in Peshastin. Now, I'm wondering if you can guess the theme of our episode today. These giant rocks around me may have given it away, but our theme today is rocks, or more specifically, geology. Geology is the study of the earth, rocks, and the processes by which they change over the time. It is an earth science, and today we're going to learn all about it.
It may seem like the earth is made up of one big solid rock, but it's really made up of a number of parts. You can think of the earth as being made up of a number of layers, sort of like a hard-boiled egg. These layers get more and more dense the closer to the center of the earth you get. On this hard-boiled earth, you can see the major layers of the earth. The crust, or the shell, on the outside. The egg white resembles the earth's mantle. And the egg yolk, at the center, represents the Earth's core. Let's take a look at what this would really look like if we cut into the Earth. The crust is the thin outer layer of the Earth where we all live. While it looks thin in this picture, you don't have to worry. We're not going to fall through by accident anytime soon. The crust ranges from around 5 miles thick in the ocean floor to up to 25 miles thick on land. That's about the length it takes to get from Leavenworth to Wenatchee. The crust is made up of rocks and minerals. Below the crust is the mantle. The mantle is much thicker than the crust. The mantle is almost 1,800 miles deep. That's about the same distance from Wenatchee all the way to the U.S.-Mexico border. The mantle is made up of slightly different rocks with more metals. The Earth's outer core, which is below the mantle, is made up entirely of metal, in particular iron and nickel. The Earth's outer core is very hot. It is so hot that the iron and nickel are liquid. At the center of the Earth is the Earth's inner core. The Earth's inner core is made up of iron and nickel, just like the outer core. However, the inner core is different. The inner core is so deep within the Earth that it's under immense pressure. You can see the layers above are pressing down on the inner core. There is so much pressure upon the inner core that even though it is so hot, it is completely solid. The inner core is the hottest part of the Earth, and at over 10,000 degrees Fahrenheit, it's about as hot as the surface of the sun.
Hello, Brandon here. The Earth has countless rocks. In this episode, we're going to be looking at 3 main types of rocks that all rocks can be classified as: igneous, sedimentary, and metamorphic. We'll learn about how these rocks are formed and what they're made of and how you can identify them.
Join us on a walk in Wenatchee and Leavenworth as we explore the 3 main rock types.
Welcome to the Rock Show!
Hi, it's Elisa from the Wenatchee River Institute. For today's Rockin webinar, we're going to be looking at a sedimentary rock, which is right behind me. We'll get a closer look. These rocks are located in Wenatchee near the Stemelt Creek area. The sedimentary rocks are shaped like cylinders and are a creamy color with a bit of gray. The way to identify that they are sedimentary is by noticing the bands or sections that run horizontally or side to side like cake layers. Sedimentary rocks are formed by the accumulation of layers, and these layers are brought in and transported by the wind. Many of us in Wenatchee know the story of Saddle Rock, where Coyote turns the two bears into stone. Use your creativity to create a story for these rocks. What shape are they? What do they remind you of? What's your story?
Hey, it's Naomi from the Wenatchee River Institute, and today I'm at Jacobson Preserve in Wenatchee, and I'm standing today on an igneous rock. Igneous is the Greek word for fire, and igneous rocks are formed when magma solidifies. And magma is made up of melted minerals that typically originate deep within the Earth's surface, below the crust, in the mantle. Igneous rocks are classified into two groups depending upon where the magma solidifies. When the magma remains inside the Earth's crust, the rock is classified as intrusive igneous rock. When the magma exits and cools as lava at or near the Earth's surface, such as in a volcanic eruption, the rock is classified as extrusive igneous rock. Exposed to the relatively cool temperatures of the atmosphere, the lava cools quickly. Hey rock stars, let's talk about metamorphic rocks.
Just like a caterpillar undergoes a change or metamorphosis to become a butterfly, metamorphic rocks also undergo a change or metamorphosis. Metamorphic, metamorphosis. Metamorphic rocks are rocks that have undergone a change, usually from heat or pressure.
Metamorphic rocks began as igneous or sedimentary rocks, but have undergone immense heat and pressure within the Earth's crust.
Sometimes you can see bands of color or sparkles within them. Some examples of metamorphic rocks within our own area would be behind the Fred Meyer in Wenatchee on the Loop Trail, or in the Shawakam Mountains, or what's called the Ingalls Tectonic Complex. In the Ingalls, you can find a metamorphic rock called serpentinite, called such because it was thought to have resembled the scales of a serpent.
Serpentinite was once igneous rock, but it was transformed through intense heat and pressure. It was twisted and melded and smushed, and this serpentinite was formed over time. Kelsay Stanton, a geologist studying at the University of Washington for a PhD in Earth and Space Science, took some time to virtually sit down with us and talk rocks and volcanoes in the North Cascades.
Hi, I'm Kelsay Stanton. I'm a geologist. Geologists think about Earth and Earth processes. There are some geologists that think about rocks and sediments and how they got to where we found them. There are some that think about rocks and the metals that we find in rocks and how we might use those. There are some geologists that think about earthquakes and landslides, or how rivers form the channels that they do, and some that think about volcanoes. Here in Washington State, we have a lot of really interesting geology. You could see it all over the place. One of the most obvious geologic features are the Cascades. Okay, so they run from north to south in Washington State, from British Columbia here in the north down into Oregon. So we're not the only state and province that has Cascades. Right? And the Cascades are actually mountains that were formed in different ways, different processes. There are parts of the Cascades that are composed of folded and faulted rocks. So here's my folded rocks. And these were pushed up really high. Okay, and then on top of those, there's also a bunch of volcanic rocks, right? Those come from volcanoes. And the newest part of the Cascades are the volcanoes that we currently see. Right? They sit right on top of all the folded and faulted rocks and the old volcanic rocks. And these volcanoes are the ones that we could see anytime we drive around, like Mount Rainier and Mount Baker. And if you drive up to Lake Wenatchee, you might see Glacier Peak, right? And then finally, like in that picture right behind me, Mount St. Helens, right? That's a picture of Mount St. Helens erupting in 1980. Okay, and these cascades, these new volcanic rocks, new volcanoes, they started forming about 4 million years ago, right? Things take a long time in geology, so they're the newest, and they formed 4 million years ago. Let's think about those volcanoes a little bit more. We'll zoom in on these volcanoes, right? So there's our volcano shape. And our cascade volcanoes are called stratovolcanoes. Okay, stratovolcano. The strato means layers. So these are volcanoes that have many, many layers. And the layers are ash and lava flows, right? Because these volcanoes, much like in that picture, that's a big ash flow coming out of the volcano, a big ash cloud. These volcanoes, when they erupt, there's a lot of ash that comes out of the top. So the layers, the strato, are layers of ash and volcanic rock, lava flows. Okay, and so let's put a little volcanic neck here where the magma and the ash are coming from. Right, so that's in the center of the volcano. And the magma is being formed very, very deeply. And it's being formed because of tectonic plates. We could talk about tectonic plates some other time. But you can just know that the magma is coming from really deep in the earth, miles and miles down. Okay? And as the magma starts to rise, it starts to depressurize. It doesn't have as much rock pushing down on it. And there's a lot of gases in that magma, and because it doesn't have the rock pushing down on it, it wants to escape. It wants to burst out, and that's what drives eruptions. So you might ask, how hot is the lava that comes out of these stratovolcanoes? Okay, so this lava is called andesite. Andesite. When you become a geologist, you still have to spell, even if you're not very good at it, like me. Andesite. Okay, that's a kind of lava. And it is about 1,000 degrees Celsius. Okay, and so here in the United States, we normally think in degrees Fahrenheit instead of degrees Celsius. But to give you an idea how hot 1,000 degrees Celsius is, most of the time a comfortable room temperature is about 23 degrees Celsius. Okay, so 23 is around 70 degrees Fahrenheit. And so 1,000 degrees Celsius is very, very, very hot. Way too hot to touch. All right, so next time you drive over the Cascades or you drive up to Lake Wenatchee and you can see Glacier Peak, you can think about the lava that is erupting from there and how those volcanoes might have formed. See you next time.
Every rock can give us information on how the Earth has changed over time. This rock here can even give us clues about organisms that lived in the distant past.
Now it's your turn to get outside and explore the rocks around you. Go on a hike in the foothills or walk around your neighborhood. What kind of rocks do you find? What are their colors, shapes, and sizes? How do you think they formed and came to be over time? Collect rocks and sort them by their shape, size, pattern, or texture. Stack those rocks to make a tower or a cairn. Most importantly, have fun and rock out!